Okay, so this policy uh, for each of the actions uh, gives us point zero point 0.5 probability. So if I'm in this particular state, I have two actions. I can choose study or I can choose Facebook, and both of them have equal probabilities equal to zero point 0.5. So we will learn how to calculate these values based on these probabilities in the next slide. We have the same Bellman equation that we had for our states for action values. So uh, we have exactly the same equation. So as we had the expectation of immediate reward plus our discount factor times the value of the next state, we have in this particular state in this particular case, for action value function, again, we have the same reward and we have the next action value that we should use. So uh, we can show it as a graph uh, uh, for calculating when we have a policy which chooses our action for us. If we want to calculate the value of a state, it would be the probability of choosing each action times the value of that action. So it is really straightforward. So if we had the value of each action, in order to find the value of that state, it would be the expectation of those action values. In other words, we have to multiply the probability of choosing each action by the value of that action that is has been calculated, and uh, also, we can write it on the base of our state values. Uh, the value of uh, action in a particular state can be calculated as the reward that we get from doing that action, from choosing that action in particular state, plus our discount factor. And after doing that action, when we do that action with different probabilities, we would go to different states. So we have to multiply the probability of going to the next state after choosing that particular action to the value of the next state. And we can write down these two formulas together whenever you are in a state. And in that state, you can choose different actions. So let's say that this is one action and this is another action. After choosing that action, uh, depending on the probabilities that we have in that environment, you would end up in different states. So in order to calculate the value of a state, we would have to multiply the probability of choosing that particular action in that state. After choosing that action, I would get a reward. Also, I have to calculate the expected value of the next state that I'm going to end up after doing that action. So this would be the formula for calculating the value of a state based on the value of the next state that we are going to end up if we follow that particular policy. And we can write it down in the using the action value function. Whenever you choose an action in a particular state, you end up in different next states. And after ending up in different states, again, you can choose different actions in the next state. So the value of a state action going to be the reward that you do, reward that you get after doing that action in a state, plus uh, your discount factor, the probability of going to the next action from that particular state after doing that action. And in the next step, the probability of choosing the next action and the value of the next action. I'm going to show you these formulas in this slide. How can we use it? So I want to find the value of the next state. Let's say that I don't have this value. So I don't have 7.4 and I want to calculate it. The way that I calculate it is that I have to consider the probability of choosing the next action. I have two actions. The first action is study, and the second action is pop. So I have two actions. The probability of choosing the first action, according to the policy that we had in the previous slide, the probability of choosing action uh, is zero point 0.5, the study action. I have to, multiply it by the reward that I get. So 1 plus, uh, sorry, I made a mistake. The reward that I get here, the reward that I get after doing that, the particular action is 10 plus our discount factor. Here, our discount factor is equal to 1. Our policy was in all of the states and actions, our probabilities were zero point 0.5. So the probability of choosing an action times the reward that we get plus our discount factor, which is 1, times the probability of going to the next state. So in all of the cases, when we choose study, we end up in this state. So with 100% probability, I'm going to get in this state, which its value is 0, plus the probability of choosing action pop, so zero point 0.5, times the reward that we get from choosing that action, which is plus 1, plus our discount factor, times uh, here, whenever I choose action pop with zero point 0.2 probability, I go to this part, to this state. So it is going to be uh, zero point 0.2 times minus 1.3 plus with zero point 0.4 probability, I'm going to get 2.7. So zero point 0.4 times 2.7 plus with zero point 0.4 probability, I get back to this state. So zero point 0.4 times 7.4. So if you calculate this value from here to here, you would get approximately uh, 7.4. So this tells us that in this situation, in this particular MDP and all of the MDPs actually, the Bellman equation holds. But we haven't introduced any method for calculating these values. As you saw, to calculate this value, I had to use this value in my calculation. So it is recursive. Okay, let's have another example. Here I want to calculate this minus uh, 1.3. So again, we have two actions. We have action study here and action Facebook. So with zero point 0.5 probability, I choose that action. So times, let me write it better. Um, zero point 0.5 times if I choose this action, I would get -2 reward, so the immediate reward, plus my discount factor, which is 1 in this problem, times the probability of going to the next state. The probability of going to the next state here is 100% or 1. So with 100% probability, I go to the next state, and the value of the next state is 2.7. So 2.7 plus, again, the probability of choosing the other action is 0.5, and I have to multiply it by the reward that I get, which is -1, plus my discount factor, which is 1. The probability of going to the next state, we have only one arrow here, which is 100% probability, times the value of the next state, which is -2.3. So -2.3. So we have to calculate this value. So we have -2 here, and we have 2.7 here. We would get uh, zero point 0.7 here. If we multiply it, we would get uh, 0.35 plus. Here we have -1 and -2.3, which if we add up these, we would get -3.3. And if we have it, it is going to be minus plus minus 1.65. Am I right? Yeah, minus 0.65. And if I add up these values, I would get minus 1.3, as you see here. So using the Bellman expectation equation, we can find these values as you see here. Okay, that is all that I want to talk about in this session. We will continue our discussion in the next session.